Hi, Miss Berman and Mrs. Olson. Sam and Bashkim here presenting our law of cosines problem
about a hockey game. And our problem is, in a hockey game, Patrick Kane and Jonathan Toews are skating up the ice, intending to score a goal. Kane stops 37 feet away from the goalie, and Toews stops 43 feet away from the goalie. The distance between Kane and Toews is 18 feet. If the goalie is faced toward Kane, what angle does he need to rotate if Kane passes the puck to Toews?
So to start this problem, we know we have to use the law of cosine, so of course it's going to be a triangle. So we made a triangle representing the distance between Kane and the goalie, which is one line of the triangle, Toews and the goalie, which is the other side of the triangle, and the distance between Kane and Toews, which is the final side of the triangle. So we know that Kane is 37 feet away from the goalie. So side JT, representing Jonathan Toews, is 37 feet. And since Jonathan Toews is 43 feet away from the goalie, side DK is 43 feet. And the distance between the two is 18 feet. So we know our application for this problem is to find the
side, this angle
theta
that the goalie has to turn. So to solve this problem, we have three sides, so we have to use the side. So we're using the law of cosines.
So our equation is cosine theta equals b squared plus c squared minus a squared, all divided by 2bc. So our b squared in this case would be 37 feet, because that is represented by side JT. And our c squared in this case is 43 squared, represented by side PK. And our c squared would be 18, because that is representing the distance between the two players.
So now all you gotta do is plug the numbers into the cosine formula, law of cosines, and you'll end up with cosine of theta is equal to 2,894 over 3,182. And then you take the inverse of cosine of both sides, and you end up in as theta is equal to 24.565 degrees,
Which is the
angle that the goalie needs to turn in order to block the shot from Patrick Kane or Jonathan Toews.